What does a lithium battery look like? How is it recycled? What is all that process that goes on behind the scenes? This looks to me like a chocolate bar.
Cobalt, nickel, manganese.
Hello and welcome back to Artisan Electrics. Today we've got a really exciting little video for you because we're here at Lithium Battery Recycling Solutions. We're here with Alan, the head of this whole operation, and he's going to give us a little in-depth tour into what they get up to here because there's some really exciting cutting-edge stuff that's happening here. We're here as electrical contractors installing the electric vehicle charging points for them. You might have seen that in another video. We've installed two 22 kilowatt MyEnergy Zappy charge points that will enable them to harness the power from the batteries before they go for recycling, discharge those batteries and then put it into Alan's Tesla here or the electric vehicle of some of their other staff in order to make the best use of that energy rather than it just being wasted. So that's all part of the recycling process, but we want to go a little bit more in depth now in this video and show you what does a lithium battery look like? How is it recycled? What is all that process that goes on behind the scenes? Because a lot of people think about buying an electric vehicle, but they don't think about the end of life process and all the planning and preparation that goes into that. And that's what Alan's business is all about. So Alan, do you want to take us inside and show us what goes on?
Yeah, sure, I'd love to.
This looks pretty impressive. So
yeah, no, it's welcome to the operation.
Thank you.
I mean, essentially where it starts from is obviously getting the batteries here. So that's where you can see all of the packing crates on the racking. We don't just take batteries which are in an okay condition. We've got batteries which are actually damaged and defective also, and some critically so. So we've got a broad range of packaging to be able to meet those requirements.
Okay, so these the kind of metal crates that you're talking about?
Yeah, no, some ones dotted around. There's some ones where they look like little mini bomb crates as such. You know, they're heavily modified so that they can cope with essentially high temperatures if you should have thermal runaway with a battery under normal conditions of transit.
So what are these guys doing?
Okay, so once we've got the battery here, then essentially we're taking the battery down to a modular level, and that does a number of things. First of all, it mitigates any kind of high voltage, any kind of dangers that we might face. I'd prefer to deal with 20 volt batteries as opposed to one 600 volt.
Yeah.
You know, and as an electrician, you're going to know how fatal things are.
Yeah, so essentially these are all connected in series, right? So the voltage increases as you add modules.
No, each battery pack from the manufacturer is different, but yes, they'll be connected in such a way to develop the best voltage going to the car. Yeah. But being DC voltage, it's slightly more deadly than AC voltage, I think you'd agree. Yeah,
we were talking about that on our solar video because it never passes through zero, so it arcs and it doesn't stop you.
Indeed.
And if you're holding on to it, you're a goner.
Indeed. No, very small milliamps to sort of be fatal.
Yeah.
But obviously once we've broken those down, then you know that is the first stage in making things safe, and then we have a number of different options then afterwards. The normal kind of routes are essentially a second life or a reuse, which is a good way of reusing the battery because it can be used for other things which are less demanding, like power supplies. But the other side of things, which probably we're going to be more tailored towards, is end-of-life remanufacturing of getting into the materials inside, so that we can then recycle and recover them in a circular economy way. Inside a lithium battery is a lot of complicated stuff, and you've probably heard different types of metals that are inside there, precious rare earth metals like cobalt, and you've got nickel, manganese, and the lithium obviously itself. And these are rare materials which are going to be in demand as obviously the pickup of EV goes about, and especially when it's mandated in 2030 in the UK that we're now not going to be able to buy a petrol or diesel engine car from that moment onwards.
Yeah, and of course when we talk about these rare earth metals and just all the raw materials in general, recycling them and you know harnessing taking them out of old batteries is a lot better than having to mine them again from the start, isn't it? So,
yes, yeah. Well, cobalt, the world's national reserves is in the Democratic Republic of Congo, and there is quite a few poor connotations with dealing with that, like child slave labour and things like that, which no one wants to be associated with. Exactly. But no, absolutely, there is only such amount of resource in the world as such, and of course, if we can remine from surface mine the products that we've got, then that is going to ensure the technology ongoing.
Cool. So can we take a look inside one of these and see what goes
Sure.
on inside?
Yeah.
So this looks to me like a chocolate bar, maybe like a nice, delicious galaxy.
Right, so lithium-ion pouch cell is what it is. So lithium batteries actually have a number of different manufacturing ways as such. So this one is what's called a pouch, so it's flexible, it's in a foil container. Other common ones you would probably more likely to see is like a canister cell. But in a canister form, you would actually have them stacked inside an EV battery, many thousands of them, and that's what's in the Tesla. Essentially, it's made up of many smaller, very thin foils, which make up the anode and cathode, or the positive and the negative. And there's many different layers there. So you've got an anode, a cathode, separated by a plastic separator, a thin plastic separator, and the materials which are inside are covered in graphite and carbon black, and that's where the cobalt and the nickel and the manganese is actually inside.
Wow.
So the difficulty is trying to get that material out.
Yeah, okay, and we'll talk about that in a minute and how do you separate it all. But just so our audience knows, this isn't actually a live charged up lithium battery, is it? It wouldn't be safe for me to be handling it like this. So this is just a dummy one, right?
It is indeed, yes. So we've got a dummy cell as such. So there's a lot of training that needs to be goes on with lithium battery handling, obviously with high voltage, and also testing as well. So before a battery goes on the road, it needs to have type approval testing. So things have to be dropped, things have to be stabbed, things have to be burnt. So lots of things have to be tested before it's safe to go onto the road. So this is actually a dummy battery. It's got all of the materials in it, bar one important ingredient, which is the electrolyte, which is both a flammable and a corrosive.
Okay, so am I allowed to cut this
open?
Yeah,
let's cut in, let's see what's inside. Get some gloves on though, because we're dealing with some hazardous materials.
Okay, let me get my knife. Right, so what is this first layer?
Right, so what you can see then is essentially a multitude of layers inside. So you can see there, all folded up like in there.
Wow.
Now, each one of these, you've got a plastic separator. You've then got an anode, essentially, or the negative part, which is inside there. It will scrape some off, and that will be copper. So you can see the copper flakes coming through.
That's amazing. Yeah.
Yeah, and then that is then got another separator, plastic separator. And then on top of that, we've then got the cathode, or the positive, which is an aluminium-based foil, and this has got the cobalt, the nickel, the manganese, and all of the other rare precious metals. But underneath that will be silver.
Okay, yeah. Oh yeah, we've just
gone
broken
right
through.
through.
Yeah, so it's quite fragile, that, isn't it?
Yeah.
It's quite kind of crispy.
Yeah.
Wow.
So
and it's
each one
just layer after layer.
It's layer after layer, and you can see there's an awful lot in there.
Yeah.
And this is the fragility of the battery itself, because all it takes is essentially some damage to go through, and then you've got all of these positive and negatives actually touching, and that creates a short circuit and heat. And that's what obviously creates the thermal runaway as it actually goes through the battery, and also goes to the next cell and the next cell and then the next pack, and obviously it creates a very difficult fire to tackle.
So are these connected at the ends somehow? Are they
That's
linked,
right,
like just linked to each other? Yeah.
Yeah.
And I peel. Oh, I see. Yeah. So you've got all these copper tabs at the end. Yeah. Basically.
That's it.
Wow.
So pretty intricate stuff.
That's amazing. Yeah, and then they're all connected.
Yeah.
To the whatever it is, the negative this side, and then the positive that side.
Yeah.
Yeah. Amazing. How many volts would you get out of this one little pack, just out of interest?
I think most cells are 4 volts, 4.2
Okay.
volts.
Yeah.
I mean, a lithium-ion cell 18650 is 3.7, but when it's charged, I think it shows 4.2. Yeah.
So how do we get then from this to the raw materials? How does that work?
This is the bit we're working the hardest on, the thing to consider is that there's no metallurgical treatment in the UK currently, and it hasn't been since we took our journey when we started in 2012. We actually mechanically shred the batteries once they're discharged and they're safe to do, and then it's that resultant shred as such that then needs to go on for further recycling.
Okay. So you take it from the battery pack, and then inside the modules are the cells.
Pretty much, yeah.
Yeah.
And then we're obviously able to sort of put the modules through a shredding process to be able to then recover the materials.
So if you, I understand this is going for second life probably, but if you were going to be recycling this, you could put a whole module like that through your shredder?
Indeed,
You
yes. Yeah.
break it down into nice little flakes of different materials.
Indeed, yes.
Have you got any of that stuff that you can show us?
Yeah, of course. Let's go and have a look.
Cool. So from that lovely chocolate bar-like pack that I just split open, you shred it and it becomes this. Is that correct?
Yes, it's one of the stages, but this is where you can see, obviously, in a commercial scale, how we can try and obviously start to get to the materials, and you can start seeing the folds of the internals as such, all of the plastic separators, all in there. But once we've able to obviously get into it, then this is the start of the lithium battery recycling process. You can see the flecks of the copper, and you can see the aluminium. Obviously on the battery cases, we've got the likes of some big thick bits of copper, and
chunks
some
of
chunks of
aluminium
aluminium.
there as well.
But essentially this is the beginning, so that we're then able to go to a series of other steps to be able to segregate the individual components ready for second life and second reuse.
So essentially you're taking something that was very dangerous, you're disarming it, effectively making it safe
Charging
to
my
then
car.
recycle, and charging your
my
car from it.
Yeah.
That's really cool.
Yes, yeah. No, I think the danger levels can't be stated enough. Obviously, we're dealing with some very dangerous things, and you've only got to speak to Richard Hammond when he had his crash, and the car obviously took sort of 6 days or something silly like that to go and get put out. I mean, the lithium batteries have got an immense amount of energy inside them, hence the reason why we use them. But to recycle them safely, we have to treat them really with very kid gloves and the right equipment and training to be able to get to even this stage.
So what will be the process then? Because this just looks like a big mess to me. How on earth would you separate all of these various
this is the
parts?
start. This is the start of the journey. So the white stuff in regards to being the plastic separator is light and fluffy, and going over some form of a conveyor belt, it can actually be blown away. The other things that we can do is we can granulate this even further, and in which case this is where you start being able to separate the black mass, as we call it, which is the coating which is on the foils itself, away from the metal underneath.
Yeah.
And as you can see here, even just from our rudimentary shredding that we've done, we're able to get to a clean bit of copper. So essentially this is the beginning steps of being able to recover the materials separately.
And I know, being an electrician, how much copper is worth at the moment.
Yes,
the copper prices just seem to be going up and up. So I guess a big battery pack like the one that we just saw, I mean, how many kilos does that weigh?
Well, a big battery pack like that is about 650 kilos.
Wow.
But what we've got to consider, of course, is that this here is micrograms. It's so thin.
Absolutely.
The actual amount of copper that it nets is it's not miraculous, but it's enough to obviously start a recycling program going. And in fact, actually, there's little choice, because there's no other options at the moment for lithium battery recycling. So it's got to start from somewhere. You've got the fasteners.
It's copper, but then you've got the screws, which are presumably not copper. They're stainless steel or something like that.
Yeah, or titanium.
I tell you what, then, what we haven't seen is the process of actually, when you get the modules, when they come into you, how do you actually discharge them? Can we show that?
Yeah, of course, yeah. Let's go and have a look.
So this is the kind of discharge station, is that what you would call it?
Yeah, no, well, we've obviously sort of put something together for you to see today. We obviously deal with quite a few different OEM manufacturers that are a bit precious in regards to their batteries, so we have to be careful. But essentially, it sort of demonstrates the process. So we've got obviously modules inside there, hooked up and wired up to the bi-directional power supply, which in itself is hooked up to the grid, and now our vehicle chargers.
So how many volts DC are these batteries kicking out into your discharge unit?
Roughly on this bank of here is about 2.4 kilowatts.
Okay, and that's kilowatts. And what kind of voltage are we talking about?
Each one of these packs is roughly about sort of 40, 50 volts.
Okay, so it's basically this, what did you call it?
A bi-directional power supply.
This bi-directional power supply is converting that voltage, that DC voltage,
yeah,
and then it's converting it to AC voltage,
yep,
which you are then feeding back into the building and using to run.
Right, yeah.
Using to run this
Yeah,
building.
that's right, yeah. So we've obviously got heat and light, and we've got our power tools and now an electric forklift truck as well that needs to be charged.
I saw that earlier. That's great.
So yeah, no, getting fully embraced into the EV life as such, and then of course, the shredding technology that we've got, which unfortunately I can't show you today, but yeah, that obviously takes an awful lot of energy also.
And presumably the state of charge that these come into you at varies, does it?
Oh, absolutely, yeah. No, we they don't all come to us 100%.
No, they don't charge them up for you.
No. In fact, actually, we probably encourage the opposite.
Yeah.
I mean, something which is at high voltage is obviously clearly a lot more dangerous to handle and deal with.
Yeah.
So again, I mean, our protocols in where we collect from the customer base is strictly monitored. We have to know what we're dealing with, and we ask some specific questions to them. And state of charge is a very important part of that.
So this bi-directional power supply, what sort of voltages can it deal with?
120 volts and 5 kilowatts at the moment, and as you can see, it's in a rack mount, so we're able to obviously extend into that. We're actually starting our journey with the mechanical separation side of things at the moment, and we're already making sort of inroads into the next steps of obviously getting more equipment in, being able to have more capacity to do more batteries.
That's fantastic. So from this, it feeds into your distribution board, and that's where we've connected our electric vehicle charging points, which are designed to be able to harvest that energy and use it rather than selling it out to the grid to charge your Tesla and charge other electric vehicles. I've seen quite a few electric vehicles around on site. Obviously, various staff members are going that way, aren't they?
I am the first one perhaps with a Tesla, but I'm not the first one with an electric car or even a hybrid cars. And all around the main company buildings, we've actually got electric vehicle charge points. Although I've got now the best ones.
Yeah, that's it. Well, I really appreciate you showing us around here.
That's all right, my pleasure.
It's super fascinating. I absolutely love what you guys are doing. I think it just totally makes sense. And you're going to have a lot of work on your hands, I think, over the coming years as more and more vehicles reach their end of life for whatever reason. They're going to be sending the batteries your way, hopefully.
Absolutely, we certainly hope so.
So if our viewers want to find out more about what you guys do, where can they find you?
Yeah, no, we're Lithium Battery Recycling Solutions, so you can actually see us on our webpage or go to Corley's, www.corleys.co.uk.
I'll leave a link in the description.
Thank you.
So that anyone who's interested can check out what these guys are doing. It's really awesome, and really appreciate you giving us a little sneak view into what's going on here. It's super exciting, and it's been a pleasure for us to work for you guys this week and help you on your journey as well.
Thank you very much. Cheers.